for today's class, we're learning about a data structure called lists, right? So lists are a very, very interesting part of Python that you wouldn't want to miss. Now, for some people for all of us that are going to data, not for some, I believe all of us here that are learning Python is because we want to go into data, or you want to, you know, so lists form the foundation of what you're going to be using, right? All throughout your data analysis career. In fact, you've learned something like the integer, you've learned about the strings, right? Now today we're learning about lists. Topic is introducing lists or introduction to lists. So we're going to see what lists are, how to create lists. We're also going to see how to access the elements of a list. We're going to see how to modify a list either by adding, removing, or changing the contents of what a list is. And we're also going to be seeing, lastly, how to sort a list. So, what is a list? Now, a list is one of the many data structures we have in Python. We have so many data structures. We have lists, we have dictionaries, we have sets, we have tuples, right? We have so many collections of elements, right? So, a list is a collection of items, right, in a particular order. Now, is a list is a collection. Of course, all of the structures I spoke to you about, the tuples, the dictionaries, all of them are collections, right? But a list is a special kind of a collection, right, of items because it collects items in a particular order. That is, if this is the first item that appears on the list, it's always going to be the first item, right? So some definitions will say a list is an ordered collection of items. It's still the same English, right? Or you can say is a collection of items in a particular order. Maybe you're more like simplifying the language now. So that's what a list is, right? So as of last week, we saw where we were calling a variable, maybe like name is equal to Manasseh, name is equal to Ibrahim, name is equal to Salome, name is equal to we give all of ourselves names, but then here we can actually create a list of names. There are cases where, okay, what if you wanted to collect a list of people in your class, in the entire class? Of course, the name won't just be one. Or will you be collecting name one equal to, you can actually use name one, name two, name three, name four, or you can collect all of them in a list. And that is a better solution, right? Of course, I'm going to explain what I'm saying just now. So this is a list containing bicycles, right? Common bicycle names. On the contrary, we are going to be using names of people, right, on this so that it will relate more to what we are doing. I don't know. I did not. I'm not sure. I think when I was growing, I was a fan of bicycles. But I'm not sure if I know the names of these bicycles now that are here. I think the one we used to use then is not the names are not here. That was on a lighter note. Okay, so of course, let's do collab.google.research.com. Let's do collab. After the break, when we come back, we'll do work with an offline Jupyter lab. Right. So of course, it's a new notebook, brand new notebook, and of course, this is week two. Okay, I was waiting for this to pop up. First things first, rename your notebook. Some of you don't rename your notebooks, and then in the end, when let's say your PC goes off and then you want to go and start searching for this notebook in your Google Drive. Okay, hope you know that once you create this, a copy, this is created in your Google Drive. So you can go back and access it in your Google Drive, right? Just in case if you lose it and then you're sweating to find it, it's in your Google Drive, you can just go and find it there. You can just type the name and it will open for you. So I'm just going to add a text cell above. Then I'm going to call the topic list for introduction. Oops. To lists, yeah. Okay, let me make this a topic. How many of you remember how to do that? Just add this, right? I can even bold it. I just like playing with these guys. I mean, the more you play with them. The more you learn, introduction to this guy. I got the spellings right. So of course, like I was trying to say, you can actually do name one is equal to, and I say you can do name two is equal to Ibrahim. You can do name three is equals to Hawa. Of course, you can do all of this, and then of course they still work. So if you want to print them, you can come back and print them. You can come back and do print name one. So if I print all of these guys, let me see what I have. You can see Manasseh, Ibrahim, Hawa. Of course, they work. But this is me assigning multiple variables, right? To this particular, So it means if I have 1,000 names now, that's how I'll be typing them. That's actually not how data analysts think, right? So instead of this, we store these guys in a list. So I can just come here and just put names as the list. And then this is how a list is created. You use square brackets like this. Square brackets. We have many kinds of brackets. We have the parentheses, we have the curly braces. I will show you how all of this fit in as we continue to go. But for the sake of this class, we use square brackets for list, right? So I can type, of course, since it's a string, I can use the double quote, Manasseh, Ibrahim, of course. Hawa, do we have any Hawa in this class? Okay, great. Now you can see I have a list, right, containing all of these names. Now this list now I don't have to be typing print, I can just use one print and then it gives me all of these guys. There is so much advantage using lists. As we continue to go through the learning journey, you will see the advantage. Let us also do this. Let's print out this kind of list before I give you an exercise. Norms, let's just create a list of numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Of course, now you can see norms. So instead of saying num one is equal to one, num two equal to two, num three equals to three, I can just print them here. I can just say, I can just say print nums, and then it will just give me the list, right? So there is so much advantage to this. Now this can be like a column of data, right? Names can be the column. This can be nums. Oh, you know what? Let me just add another list here and call them ages of people. So I will just create another list that corresponds to their individual ages. Let's say the first person age, let's say is 15. Second person's age, let's say is 45. The next person's age is called it 33. Say 33, right? So I can print name, right? I can also come back and print their ages, right? And then of course I have names and I have ages. So this can be like your column of names. So I'm trying to relate it now to what you're going to be learning later about data analysis. I want you to have that impression as you're learning. Of course, there are many ways, there are many things you can use Python for, but I'm trying to make sure that you're learning Python for data analysis, right? We have now seen how to create a list. We have seen a list of people, right? And we have also seen a list containing ages, right? So now you know why we are having these names enclosed within a pair of double quotes is because they are strings, right? And so if you write this without this string, it's going to throw an error. Of course, we saw that from the previous class, right? So let's go back to our book, see what our book has to say. I think we've learned a lot. So this is them now creating a list of bicycles, and they've printed a list of bicycles, right? So now, how do we access elements in a list? For example, now, if now I have names and I have ages, right? I also have norms. So let me print names. Now I have this. Now just like Excel, right? No, let me do this on Google Sheets. Let me show us something on Google Sheets. Since some of us are going to go into data analysis, let me show us something on Google Sheets quickly. Okay, let me open a new document. Okay, no harm, let's just use this. Now, this is just a data set from someone's task. Now, look at this. You find out that to the column it attaches an alphabet, to the column, rather to the row, it attaches a number. That is the same thing with Microsoft Excel, right? You can see this is column A, this is column B, column C. Whereas this is row 1, row 2, row 3, row 4, row 5. So automatically, even if you open a blank worksheet Let's open a blank worksheet here. You see, it's already blank, but Google Sheets, or yeah, if you the spreadsheet application has automatically given labels to these rules, right? It has given them labels. So this is what we call an index, right? And we have two common kinds of indexing. Two common kinds of indexing. I'm not saying those are the only kinds of indexing that exist, but there are two common kinds of indexing. There is the one indexing and there is the zero indexing. Now, the one indexing is when the counting starts from one. So, like this one now, this is one indexing. It starts from one, you go to two, you go to three, four, you go to five, you go to six, seven, eight, and so on. It starts from one. And I know you can guess already what zero indexing is. Default index of Python starts from zero. For some programming languages, is one. They maintain it like we have here in Excel. But for Python, it starts from zero, right? So zero is like your first item. So just like here, one is the first row, two is the second row, three is the third row. For Python, the first row will be zero. So now it means the index Python attaches to Manasseh here will be index what? Will be index zero. This will be index one, and then this will be index two. Do you understand? So if we want to call this one, we're going to call names, and the index we are going to return. If we want it to return Manasseh, is going to be index zero. So how do you insert this index? Now you first type the name of the list, which the name of our list in this case is what? Is names, right? And then you open a square bracket, the same square bracket you use for a list, right? And then you pass in the index here. So it will get for you that item in the index. So let's print this and see. Gives you Manasseh. Can you see? So if you return one, gives you the next one, Ibrahim. If you return two, gives you the next one. Now what will happen if you return three? It is going to give you what? An index error. Index error is when the index that you're asking it to give you does not exist, or maybe it has exceeded, is outside of the allowable index. So each time you create a list, Python automatically assigns an index or indexes to each of the elements in the list. And so if you mistakenly, yeah, I take that again. If you mistakenly call any index that is outside of the range, it's going to return an error for you. So now this indexing we've seen, which I will just go ahead and do this before you take an exercise. So you can call this name one, right? You can call this name two, and they give you this. Of course, now you can see we have to use the print statement here because it will only print the last one for us because Hawa is actually the last element. So this is where you would need to call your print guy explicitly, tell it to print this element, tell it to print also this element, right? You can also tell it to print the names too. So let's see what it gives us. Ta-da! You can see the names are now here, right? So we would even see a better way to get all of these names out. What if I want to print all of them, all of the names? If they're up to 20,000, do I have to print them manually? I know that's what you want to ask me, but for the sake of this class, it's outside the scope of this particular class. By next week, we're going to see that more. When we go to looping, we're going to see more about that. But for now, we're just going to look at how to access the elements of a list. And now this is accessing these elements, right, using their positive index. All of them also have negative indexes. Let's say now I have a list that I don't actually even know the last elements in the list, right? So of course we know that the by default in Python, the first element in the list by default is always zero, right? That's the first element. Now the last element in the list in Python, no, even if you don't know the number, the last element in the list will always be minus one. So let's try this names minus one. Let's run this and see what we have. Now you can see it return back hour, right? So if I want to get the second to the last, what do I do? Who can guess? Minus two, minus two, minus two. Great, great. I like the interactivity now. So minus two will give us the second to the last element. And then you as of course as you can guess, going forward, minus three will give you the next one. Now what happens when you try minus four? Index error because it is out of list, right? Because this is, let me go back to the names. This is minus one, this will be minus two, this will be minus three. So if you go minus four, it's like you're trying to reap where you did not sow. We've now seen how to use positive and negative indexing. Okay, so you find out that when at least when you understand the few basic things in the course, whatever it is that we're going to be learning henceforth, you find out that you have actually understood them, right? So we've learned how to access elements in a list. Of course, you can also pass the dot title to them, like you have seen here, dot upper, dot lower, it still works, right? For example, here I can add the dot upper, right? And then of course it turns Howard to upper, right? Great. So that also works. You can add that is for strings, oh. Don't forget. That is for strings. Okay, so going back to our book, let me just close this window. Going back to our book now, we can see index position starts at zero, not at one, right? You're going to read this more and then you're going to find out more about this, right? So, using individual values of a list now in, let's say, sentences to create sentences, right? So, I can say, I can say, let me create this message or let me just print directly. I can print. I say, my first name is. So what is my first name? My first name is this. So there will be names zero, right? My first name is names zero. Of course, since I'm using this kind of string, I'm going to add the F at the front, right? So that it recognizes this as a variable. So I'm just going to go ahead and print this. My first name, you can see my first name is Manasseh. So if Manasseh was if I want it in an uppercase, I can add dot upper here, right? If I want this and I can run this, my first name is Manasseh. So you can actually use this. Or you can even go ahead and then create this in a message variable, right? Okay, I'm going to have this. My first name is name zero, right? Dot upper. So you can actually do this, and then later, when you come, you know, do a print message. Oops. Hmm. Okay, names. You can see name error, right? Because they do not recognize anything I've saved previously as name, right? So we have this. My first name is what? It's Manasseh. Great. So why did I walk us through this this whole, this whole drama? Is to show us that this and this are correct, like I said in the first class. The only difference is if I need to be calling this message often, right? I don't need to be typing it in the print statement. I can just store it in a variable message, so I can just be calling it message each time, right? But this approach and these are basically the same. So you can see we can still use them as variables even inside of our messages, right? So I believe through your exercise, through the exercise you're going to do, you're going to see all of those, right? Okay, going back to our book. Now you can see you have now from exercise 3.1 to 3.3, right? Of course, changing, or if you want, you can call this modifying elements of a list. We are going to see how we can change the contents of a list. We are also going to see how to add elements and also how to remove elements from a list, right? Some people will, it will always be the nightmare of some people, right? To see how to be able to do that. Okay, so now, let's see how to add elements to a list. That's one thing I like about a list. It's one of those data structures that you can change their contents. Other data structures, you might not be able to change their structures, right? So, um, let's see. Now, which one are we going to add? Message. Okay, names. Mind you, just a bit excited. Names is this Manasseh, Ibrahim, and then Hawa. So, what if now I want to change this one, right? I want to change it to, who did I use in my class? Charity. Okay, this time around it's Choma I'm going to use. Okay, I'm going to change it to Choma. I want to change the first one to Choma, right? That's what we want to do now. I want to change the first one to Choma. So I can just access the index. of the first one. So what's the index of the first one? Is index 0, right? Let me confirm, of course. So I can just put name 0 is equal to, then I'll just give it a new name, Chioma. So once I do this, Python will go to the index 0 and override that particular name that I have there. So let's see what happens here, of course. So let me print names now. Now you can see that it changed from Manasseh to Chioma, right? So if you want to change, what you do is what? You simply just access the index and then you give it a new value. First of all, you do what? Access the index of the name you want to change, then you give it a new value. That's one way to do it, right? Now, you can see what we did here. That's exactly what we did here. So what if we want to add elements to a list, right? So there are two ways we're going to learn how to add elements to a list, right? This is us actually changing the content of this list, right? Great. So what do you want to add an element to this list? Now you can add an element to this list either at the end, right? Or you can say, okay, so I don't want to add these elements at the end of this list. I actually want to add it at a particular point, right? At a particular point. Let's say I want to add it between Choma and Ibrahim, or between Ibrahim and Hawa, right? So those are the two ways. Now, first of all, is adding it at the end. Don't forget, a list is actually an ordered collection, right? Don't forget about that. A list is an ordered collection. That is, the collection is actually in a particular order, is in a given order. And so, if you're adding, it does not just add it anywhere. No, it adds it at a particular position. So now, what if we want to add to, sorry about this. So what if we want to add elements to the end? There is just a simple method called the append method. You remember we had methods for strings like the dot upper, the lower, right, and the strips, right? We had those kind of methods. So we also have lists, also have methods, right? And some of the methods include the append method, which helps us to add to the end. Anytime you hear append, is actually adding at a particular end, right? So this time around, if we add, let's say names now, I decided to now, okay, so let me now append which other person's name. Okay, let's append Temesgen. Let's append his name, Temesgen, right? So names dot append Temesgen. Let's see this now. Now you can see the list has now added Temesgen to the end. And so you can also come here and names dot append whose name here? Nafisa. Okay. Now let's print names and see whether it has added Nafisa. You can see it has added Nafisa. So you can see, but where is it adding them? It's adding them to the end, right? And it is giving them a new index. Well, this is index 0, 1, 2. This will now be index 3 and index 4. A quick way to clarify, you can just come here and have names 5. Let's see what it gives us. Oops, out of range. It's actually names 4. Nafisa, right? Out of range. Great. So we've seen how to add now at the end. Now most times you just want to be adding at the end. In most cases you add at the end. But there are times where okay you want to add it at a particular point. That's why I'm teaching you this one secondly, because in most cases you will just be adding to the end. Right? Imagine now that you are creating a bank application for banks to register new customers. Of course, new customers as they come, their results will just be adding to the end, right? Towards the end. There is no point saying, okay, so this person's name should go and be the number one. Whether the person's name is the number one or not, it's still in the database, right? But in cases where you need, in those rare cases where you need to insert it at a particular index, what do? You use this names dot think we use the dot updates. So let's see what the dot update has for us. Oops. Okay, insert rather. Insert. The update is for list. So the insert takes, I'm just trying to show you, if you don't know what a particular function does, right? You can just, in your notebook, once you run it, you can just use, you can just add, before you add the bracket here of the method you're calling, you can just add a question mark and then run this, and then it gives you this help here. So, well, it does not have a very, very rich documentation. We would have seen what this is, what function this is, and how to use it. But now we are left on our own. So you can actually Google it, check what the insert does. So the insert, what it does is that it first, okay, first of all, you can see it collects an index. Is you're going to tell it the position where it should drop it, where it should insert the object, and then it collects the object. So it collects two things: the index where it is going to insert, and the place where it is going to insert, and the object it is going to insert. So say I'm going to insert Godwin now, Godwin. But where do I want to insert Godwin? I want to insert Godwin between Ibrahim and Hawa. Now this is index one, this is index two. And then I want it to come and take, I want it to be between Ibrahim and Hawa. Definitely the index it is going to take will be after Ibrahim, right? So this is index zero, index one. So I'm going to insert it as at index two. So it will not be the next index two, then it will shift Hawa to index three. So let's see this. Two, that is the index. And then what name Godwin? Let's run this. Okay, of course. Let's call names again and see. Hope I'm not wrong. Now you can see, right? It now inserted Godwin in between Ibrahim and Hawa, just like we had. We had Ibrahim and Hawa here, but then it inserted it, right? So you're going to tell it the index where you wanted to insert it. So if, for example, now if we wanted to always add it as the first element of the list, any new name we want to add a new name and want it to be at the first element here. So we want to insert at index one, sorry, index zero. I want to insert, let me check another participant, Bridget. Bridget. Great. So let's see. Let's try to add names. Now you can see Bridget now has become the first person in the list. So we've now seen how to add at the end. We've also seen how to add at any position. So the advantage of this insert is that it gives you the opportunity to insert where you want at any position, right? But the advantage of the append is that you don't have to tell it you don't have to tell Python the position. It knows that it is going to add it to the end, right? So we've now seen how to access elements in a list. We've seen how to add elements to list, right? Right. So now we're going to see, okay, we've also seen how to modify to change the value of an element in a list, right? So we're now, lastly, we're going to see how to remove elements in a list, right? So just like we learned how we can add at a particular position, right? And we can also remove from a particular position, right? It's the same thing with this one here. The same thing with deleting. So we can actually also delete from the end or delete from any position, right? So if I want to just delete the last element in this list, the last name, sorry, Nafisa, you're going out. So if I want to, I can just pop dot pop, and then if I do this dot pop, you can see that the default pop, the default index is telling you that you can insert the index here, right? Or you can, the default index, if you see this equal to -1, it means it is telling you that if you don't put any index here, it's going to delete the last item by default. So if I run this names.pop, it is going to pop out Nafisa. It's telling me that, oh, Nafisa, we've removed you. So let's see this. And you can see in the list, Nafisa is no longer available. So append at pop, remove. Now, the beautiful thing about the dot pop is, like I said, where it differs from the append is that you can actually specify the index. So if it's Ibrahim that I want to remove, Ibrahim is index 2, right? This is index 0, this is index 1, this is index 2. I can just come here and do this names list, please pop out Ibrahim, and then it removes Ibrahim quietly, right? So how do you know? You can just print the list again. So before it pops out, it will tell you the one that it has removed, right? So you can find out that we no longer have Ibrahim. So you can specify the index, right? Or you can also use this to specify the index. I don't even know if you would want to use it. You can use the del keyword, delete. This is del. Then you specify the index. Then you specify the index of what you want to delete. This could be names 0. Oh, Bridget, sorry, you're going as well. So let's do this. So let's print names now and see. So you can see Bridget is gone. Now we're left with only 4 people in the list. But I know most of you would want to go with the pop method. I mean, who wouldn't want? I would also want to go with the pop method, right? So if you want to go with the pop method, just like I always prefer to do it, of course. But the delete, just don't have favorites for now. Just let both of them be your favorite. If you want to, of course, if you are popping without specifying an index, the default uh, item that is going to go out is going to be what the last item on the list. Whereas you can also specify the index, right? Now, we've seen how to add elements to a list, right? I mean, we've also seen how to insert elements to a list. We've also seen how to remove elements from a list, right? Of course. Now, we've seen how to remove using dot pop. So I want you to take your time, go through these guys and then read them, you know, and then find out more. I have taken my time to just give you the overview of what these guys entail. So you go and read them at your peril, and then the book is very, very easy and very, very nice to read, right? So popping items at any position, of course, we saw how to do that, right? So what if you want to remove finally now by value? You can actually use the dot remove just like you use dot append to add, right? Dot remove now, you can use the dot remove. It will go inside the list, it will check if you have that particular thing, right? So which name now shall I remove? Dot remove. Let me take out Godwin. We have Godwin, of course. So I remove Godwin. Now let's see what happens. Names. Now you can see Godwin is not available. So let me now stubbornly try to remove Godwin again. Remove Godwin. Okay, sorry. String. Now you can see it is telling me what value error, because what you are trying to pass through, that is the what you're trying to ask it to remove, is not in the list. Even if you want to remove Chioma and then you decide now to start with small letters C, Chioma, to still throw a value error because Chioma is not in the list. The only Chioma it knows in the list is the one with capital letter C, right? So get used to this kind of errors. Of course, you're going to be seeing them. Errors are your friends. They just help you to understand what's happening. Normalize having errors as your friends, right? So we've seen how to use the remove to remove elements if they exist. And this is also applicable to numbers. So don't forget we have this list nums, which is a list of numbers from 1 to 10. You can also add append 11. And then it does what? It adds 11 to the list. So if I have nums now, what do I have? I have nums 11. So if I use the dot pop, right, and then I run this, it is going to pop out 11. So what am I left with? I'm left with numbers from 1 to 10, right? If I want to remove um, 5, if I want to take out 5, right, I'll have to count the index 0. This is index 0, index 1, index 2, index 3, index 4. So I'm going to do this. I'm going to pop out what? I'm going to pop out 5, right? Oops. I was supposed to pop out 4 rather. Sorry. So you find out that you remove 6 instead of 5 because 5 was actually index 4, right? 0, 1, 2, 3, 4. So that's a mistake some of you will make. Some of you make this mistake now that I'm saying, right? And once you remove from a list, it's almost permanent. You can't go back on your words. Once you remove from a list, it's almost permanent. It's not almost, it's permanent. So even if I use the remove, I can now decide to now this time around come back and remove 5. Course norms, if I print now, I find out that I don't have 5, of course. So I have done that. Now, somebody will ask me, so what if now I want to go back now? If you want to go back and then have your maybe let's say for me now that I accidentally popped out 5 instead of 6. Sorry, popped out 6 instead of 5. I can just delete this cell, then go back to where I had the original list, then rerun this. Or if you like, you can restart the kernel like we saw the last week. And then I can come here now and then run through these guys. Now you find out that I still have six here. It's just five that is gone. Right. I'm just saying this because these are things you're going to, these are ditches you're going to fall into, especially as people who are, some of you who are coming new, right? So if you have an error, you can just, if you once you're able to identify, okay, I remove this one instead of this one, you can just delete the cell. Then you can come back to this run all and then either run everything or restart the session and run. You can either do restart and run all, or you can just run all. That should solve the problem. Start with run all first. If it does not solve the problem, you can do restart and run all. Right? That should solve your problem. Because now you have exercises up to 3.6, 3.7. Great. So organizing a list. This is basically the last thing we're going to be doing. So what does it mean to organize now? To organize has to do with arranging, or let's say sorting, right? Now, what we've seen is that a list is actually an ordered collection, right? It's an ordered collection. The way items enter into the list, that is going to be the structure of the list, right? But then, of course, there are cases where we want to sort, right? This kind of we want to sort the elements of the list, based on either alphabetical order or based on the size, right? Based on their size, right? We want to do that. So, what if we have that case and we want to do that? What do we do? In that case, is we'll use two techniques. One of them sorts permanently, while one of them sorts temporarily. So let's see this. Let me say I have. Let me create a new list of norms. Let me just create five, two, five, six, eight, or eight. Let me just create some random list, right? So I have this. Now if I print norms, what do I get? I get 4 to 6, right? So I can sort this in two different ways, right? If I run this norms dot sort like this, if I if I run it as norms dot sort, see what it gives me. If I let me print norms now, it will sort these guys, and by default, it sorts them in increasing order, in ascending order by default. If I want to reinitialize this, I have to come and run this so that the norms now has gone back to its scattered form. Now it has also an optional argument, which we call it the reverse. The reverse by default is false. So what we mean by the reverse is if you want to sort the numbers in descending order, you now use what? Reverse. The reverse optional parameter. It's optional, you don't have to add it. Like you saw in the first time, we did add it, right? But this time around, we want it to sort the elements now in descending order, not in ascending order. So we'll use the reverse equal to true. Then this, when you now run this, what does it give you? It now does it in descending order. But if you want it in ascending order, you don't have to pass the reverse, or you can optionally just pass it as false. Still the same thing to still give you this guy as what, as in ascending order, right? So don't worry if you're getting confused. Don't worry. You're going to have the recording and then you are going to watch it. But sword is an English language word, right? All of the things, all of the methods that we've seen how to work with them are in pure English names. They carry pure English names, which will suggest to you what you will even do, right? So this reverse is just an optional argument. Don't worry, we even learn how to create our own functions by ourselves later and add arguments, right? So now, the thing is, you can see norms now has been sorted permanently. Anywhere you go to, norms now has changed. That is the problem with this method. It sorts this guy permanently. So there are two ways you can actually um, avoid this. Is either you come here, you can say, okay, I have this guy, right? Norms. So I will not run these guys. Let me just print norms here so you can see norms. You can see norms has gone back to its scattered way, right? Let me take out this guy. I want to show you something. You can create a new variable now. You can either call it sorted norms is equal to, then you write norms dot sort. So you are not actually sorting norms, but you are creating a new variable now. Now you can see nums will actually still be the same. Let's actually run these guys and see. So let's run nums and see. Oops, okay, nums was sorted actually. Ooh, so I actually thought, okay, so where we have to, it means we have to create a copy of this. I can add dot copy here, dot copy, dot sort. So let me run this. Where is it? Run this guy, this scattered way. So let me run this. You can see nums is still now left because we have, don't worry, we're going to talk about copying of lists later. Let me just take this out so it won't confuse you, right? So if you don't want to, okay, let's talk about it now. If you don't want to sort the original list, right, there are two methods. Method one is to create a copy of the list. And if you want to create a copy of a list, right, you can just do this is original norms, right? I can just create this one, a variable called norms copy, and then I'll create a copy of norms. So I'll just have this as norms.copy. So this norms.copy creates a copy of this list so that whatever you're doing does not affect the original list, right? Then once you do this, you can come back now, do norms copy dot sort. Now, if I print norms, you see that norms is still in the scattered way, and then norms copy now. Norms copy is what has now been sorted. So this is the number one way when you're sorting variables. Is either you create a copy of the original. So that is if you don't want it to affect most of the times you just want it to affect the original list. But there are times where no, you want to create a new list, right? That is a sorted version of the old list or the former list. So instead of one way to do it is actually to create a copy of the list, then sort the copy that you created, so that the original is still in its original way, and then the sorted is a carbon copy of what you have. That's method one. Method two is to use a function called the sorted function. Python has a way called sorted. So this sorted, you can just call it sorted like this. It's a function. You can just open, then you enter the list that you want. So you can see sorted norms. This sorts this guy. Now like this, it sorts the guy in what ascending order. I think I don't know. I think it also has reverse. If I'm not mistaken, let me see if it has reverse. Okay, I don't think it does have reverse. It does not bite. Let's try. I don't think it does. Okay, it does. It does. Like I said, it does not bite. Right? It does not bite. So now the sorted function will will not change the value of norms. Now you can see sorted norms. It has sorted it, but norms is still without sorting. So that's actually the easiest way if you ask me. If you use the sorted function, it will sort it for you, right? But it will not alter the original list. And you can also pass in the reverse, like I said, is equal to true. After you pass in the list, you can do comma. You can pass in the reverse is equal to true. So this order will sort in descending order. Remember, once the reverse is equal to true, it's going to sort it in descending. If the reverse is false, it's going to set it. It's going to sort it in what ascending order. Now, of course, no apologies if it sounds a bit tricky or it sounds a lot. I know, right? It's sounding a lot as if you've learned so much now. Now, just calm down. Just calm down. I'm not expecting you to master all of these things in one day. But as we continue to practice, if we go to next week's class, we will still use list in next week's class. So as we continue to use these methods, you find out that they are becoming a part of you. And that is why we are even giving you the exercises we are giving you, is to help you master all of these things. Nobody's saying you have to cram. In fact, if you cram formulas, you will not be a very, very good you will not be very, very good at coding. People who are very, very good at coding are people who understand the language, who practice. The more you practice, the more you become one with it. Just like if you're reciting the alphabet ABCD now, nobody has to come and tell you. You don't have to go and read a book that you remind yourself, okay, this is the order of the alphabet. No, but you know it by default that this is the order of the alphabet. So just keep practicing. I don't expect you to master all of these things in one day. Just keep practicing them. As you practice, you take in the exercise, take the assessment, keep practicing, and before you understand, you've mastered everything. Right. Okay, so let's just round up what we have left. So we have seen how to sort, right? We've seen how to sort. We can see we use the reverse equal to true argument. Now we call what we have inside the brackets of functions arguments, right? Okay, so printing a list in reverse order, right? We've also seen how to do that. Now, the difference between reverse order and the reverse sorting we saw, what this one that we saw here rather is reverse sorting. So now, what if you want to print the list in reverse order? Like when I mean reverse order now, I mean this is norms, right? This is norms. So what if I want six to be the first element, three to be the second, eight to be the third? I want to have it like that. That is what we call reverse order. It's not actually you sorting. Is that you actually just making the more like I don't know how to I don't want to call it the transpose. No, that's not a transpose. It's just like creating a symmetric, yeah, a symmetry of the original list. That is, this one now will come back to the first one, this one will come back to the second one, more like the swap positions. So if I want to do that, I would can just use the reverse, the dot reverse. Then you do that. So let me run this. Now you find out that 6 now came back to the beginning, right? Reverse. So the reverse keyword does not actually sort for you. It just changes the position from the last. The last one now becomes the first, right? That is the last shall be the first and the first shall be the last. That's just the pure explanation of what the reverse function does. Okay. So, okay, that's something like finding the number of elements in a list. Very, very simple. So if you're looking for the total number of elements in a list, right? Some lists can be, let's check our names list. How many elements do we have here in the names list? Okay, we have three. But what if the list is so long that we can't count? What do? We do this len. We just use the len function. The len function, if you use the len function and then you pass in the list, it will count the number of things you have, the number of items rather you have in the list. So you use this. What does it do? It return 3 for you. So what if you want to know the number of elements in the norms list? What do? We use len, pass in norms, and then it gives you. But we want you to print it, so please print. You can use the print, especially if you have multiple lines of code, especially that need printing. You can just use this print the len of norms. This will actually give you 6. So the len gives you what? It gives you the number of elements in the list. And like I said, don't worry. All of these things we practice, you're going to master them, right? And so we're just rounding up now. Avoiding index errors. We've seen index errors already previously, where we try to access an element and the index is, we ran out of the index, or for example, here motorcycles three. Of course, as you can guess in their own, this is Honda, Yamaha, Suzuki. This is index zero, index one, index two. So they are trying to access the third index. Of course, it's going to throw an index error for them. List index out of range, right? So the last element, of course, we know how to access the last element minus one, right? So that's that about that. Now, don't forget about this that I taught you. Very, very important. How to create a copy of a list. Don't Very, very important, right? If you have norms, is equal to what? Let's see norms. This is one norms is right. You want to create a copy of norms. Let's say another. Very, very important. We are not just using it because um, we want to create a sorted copy that will not affect the original list. No, it's actually a very, very important concept. Creating a copy of a list. There are two ways you can do that. Is either norms dot copy like this, right? This creates a copy of the original. So if I type in another norms, what do I get? I get this. Another way to create a copy of the class is also to use this um, another norm is equal to norms. But let me do this another norms 2 so that we differentiate it from the first one. You do this, create. Oh, I didn't teach you this. Okay, sorry guys. I forgot I didn't teach you slicing. Sorry. Let's just do that as the last thing here. So remember, we've been trying to do this names. We have from index 0, index 1, index 2. Now, there are times where you want to print from a particular index to another index, right? That is what we mean by slicing. Slicing is more like, okay, I want to cut from here and then print from here up to this particular point, right? So if you want to cut this guy now like this from index 1 to index 2, you can just open a list here, copy from index 1, of course, to index. Now you're not going to stop at index 2. You're going to stop at index. Okay, let's try 1 to 2. Let's see what it will do. It will only return one name for you, right? Let me print the names list upward so that we can be seeing the list and be making references to it. So when you are slicing, what you do is that you specify the index of the first one it is going to start from. Then you specify the index of the last one plus one. That is where it is going to stop plus one. So it's basically just like this. Start where you're going to start, comma, stop plus one. So the starting index is what you're going to specify normally. Then the stopping index, you add one to the stopping index. Sorry, I was supposed to show you this since I don't know how it escaped my brain. So now if I have these names one, two. So if I want to print from Hawa to Temesgen, that is one, two. I need to do from one to three now. This will what? This will give me Hawa and Temesgen, right? So it will print one, it will print two, and then it will stop, it will not print the third one, right? That's how Python thinks. And maybe it's because of the zero indexing. Similarly, if you want to print names, if you want to print these guys now, you can also print it from, if you want to print from, let's say, 1 till the end. Let me use norms now, so that way norms is a bit of a longer list than what we have. So this is norms, right? So if we want to print from 8 to the end, right, we can just use norms, and then what is the index of 8 now? 1 2, sorry, 0 1 2. So this will be 2. If you want to print it to the end, you can just use your this guy, this your full column. So this will now tell it, if you don't specify any number here to the end, if you don't specify any number to the end, it will automatically print everything until the end. Let me take that again. If you specify a number where it is going to stop here, this is going to print from the second element to the fourth element, right? Where is the second element here? This is the second element. Third, this is the fourth element, right? I mean by index now. This is index 0, 1, this is index 2, index 3, index 4. And then it will not print the fifth index. Now, if you're printing norms, if you want to print it from the second index to the end, you can just leave the other one blank. Python automatically knows that it's going to print it to the end. Now you can see it will start from this where index is 2 and then print it right up until the end. What if you want to print everything to index 2 from the beginning to index 2? You don't have to specify from 0 to 2 like this. If you remove it and still leave it blank, it will still start from the beginning and give you this, right? So there are times where you want to cut from the beginning to a certain index, and there are times where you want to print from a particular index to the end. So this will give you from the beginning to index 2, right? While this will give you from index 2 to the end. Now, what if I want to create the entire index? This is going to simply be this, right? I run this. and then this returns every element in the list. So that is the second way to copy an element in a list. Once you just return this, it starts from the beginning to the end. Okay, everyone. So this marks the end of today's class. Today we were able to look at lists, how to create lists, how to index them, how to also slice them. We also looked at how to modify lists, right? And also how to sort lists. Now, of course, we continue with lists next week, but we are going to look at lists from another angle, right? Being able to loop through lists, don't worry if you don't understand what all of those mean. Yeah, so next class we're going to see that. And so we're going to be talking more about lists. For now, just make sure you practice, understand the basics about lists. For next week, we're going to go into a little bit more serious, applications of lists, right? So you just keep practicing. Don't forget to like, comment, and of course subscribe, right? And also hit the notification bells so that you get frequent updates from us. Of course, this is not the only content we post on our YouTube channel. Of course, we have so many other things we post. So it will do you good if you hit the notification bells, right? So see you next class.